Okay, so let's work our way through these. So in the first case, we were solving for x, and we have two fractions. Um, what we're going to do really is we're going to multiply to get so that both of them have the same denominator, which means we're going to multiply each of them by the other's denominator over the denominator. So x minus 1 times 3x plus 1 over x plus 1 equals x plus 1 over x minus 1 times x plus 1 over x plus 1. Okay, so that's going to give us, when we multiply 3x plus 1 times x minus 1, we're going to get 3x squared. We're going to get minus 3x plus x, so we're going to get minus 2x minus 1 is equal to x squared plus 2x plus 1. And in each case, it's going to be with a new denominator of x squared minus 1, x squared minus 1. Okay, well, when we have two fractions that are equivalent and their denominators are equivalent, then the numerators must be equivalent. So now we have that 3x squared minus 2x minus 1 is equal to x squared plus 2x plus 1. And we will now try to set it equal to 0 by subtracting one side of the other. So we'll subtract the right side to get 2x squared minus 4x minus 2 is equal to 0. And that, because we can divide both sides by 2, gives us x squared minus 2x minus 1 equals 0. Well, this is not factorable, so we're going to use the quadratic formula, which is going to give us that x is going to be equal to negative b, so negative of negative 2, plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is again 1. That gives us x is equal to positive 2 plus or minus the square root of, this ends up being 4 plus 4, so we get 8 here over 2, and that gives us that x is equal to 1 plus or minus the square root of 8 over 2, which is equal to 1 plus or minus the square root of 4 times the square root of 2 over 2. These just cancel out, so we end up with 1 plus or minus the square root of 2 as our final solution there. So what we did here with the square root of 8 was we recognized that it could be broken into the square root of 4 times the square root of 2. And when I did that, the square root of 4 just simplifies to 2. And the 2 in the numerator and denominator canceled out, leaving me with just 1 plus or minus root 2. All right, the next one. Again, we're dealing with fractions. So first thing we're going to do is we want to deal with this numerator. Again, we have two different denominators, so we're going to multiply to get them to have the same denominator, and the least common multiple of x and y will be that denominator, so we're going to multiply so that both have a denominator of xy. So we're going to end up with 6y over xy by multiplying top and bottom by y, plus 3x over xy, again multiplying top and bottom by, in this case, x over x, which is just 1. And that's going to give us 3x plus 6y over xy. Meanwhile, if we rewrite this denominator as 2y plus x over xy, because xy to the negative first, as we see, is just 1 over xy. And so now we have, this is our numerator, this is our denominator. We have 3x plus 6y over xy over 2y plus x over xy. Well, because we have this same denominator in both, we can just make this equal to 3x plus 6y over I'll rewrite the order here, x plus 2y, and that is equal to just 3 times x plus 2y over x plus 2y, and that just simplifies to 3. Okay. The next thing we have here is we have this simplification, and the idea there is that this is the equivalent of 64x to the 9th y to the 5th to the power of 1 over 4. When I ask for the 4th root of something, that is the equivalent of raising it to the 1 over 4 power. So what I'm going to do is I'm going to break this into 2 to the 6th, first of all, times x to the 9th times y to the 5th. I'm going to put it back in its root form. And I'm going to turn it into this, equals the 4th root of 2 to the 4th times x to the 8th times y to the 4th times the 4th root of what's left over, which is 2 squared times x. The reason I'm doing that is because since we recognize that this is the equivalent of raising something to the power of 1 over 4, then this whole thing is just going to simplify because we can take the 4th root of 2 to the 4th, which is just 2. The 4th root of x to the 8th is going to be just x squared. The 4th root of y to the 4th is just y to the 1st, or y. And so this whole thing just simplifies to this. And then we still have this leftover piece here, the 4th root of 2 squared, or 4x. Now, if this had been the cube root instead of the 4th root, then we would have done something different. We would have made this, let's say, x to the 6th, or we would have just left it x to the 9th, since that's divisible by 3. So it's going to depend on what this number is here, how we break it up. Now, if we have something like, let's say, 27x to the 5th y to the cube. This is really the second root, so we would make this equal to the square root of, since this is 3 to the 3rd, we'll make this 3 squared here, x to the 4th here, y squared here, times what would be left over would be 3xy, and this would then just become the second root, or each of these divided by 2, 3x squared y times 3xy. All right, so this is just a second example. Don't confuse it as a solution for the first. Okay, rationalizing the denominator, which is something that occasionally you want to do. The reason is that it's easier to work with a denominator that is in a simpler form than what we have here. Get rid of square root, get rid of the subtraction there. The way we're going to do it is we're going to multiply top and bottom by what's called the conjugate of the denominator. The reason is that we know that when we multiply a minus b times a plus b, we get a squared minus b squared, and since we have square roots, having things squared will give us a real advantage. So we're going to end up then with our new denominator is just going to be a squared, or root 15 squared, minus root 3 squared, and then we're going to have root 15 minus root 12 times root 15 plus root 3. But this is all going to end up being over, sorry, I didn't mean to put that there. It's going to just end up being all over root 15 squared minus root 3 squared, or 15 minus 3, or just 12. So then when we do this, we're going to do the multiplication. We got root 15 times root 15 is 15. We have root 15 times root 3 is going to be plus root 45. We have minus root 12 times root 15, so we're going to have minus root 180. And then we're going to have minus root 12 plus root 3 is going to be minus root 36. Okay, we can do some simplifying here. So we're going to get, so we have our 15. Root 45 is equal to root 9 times root 5. So that's equal to 3 root 5. Root 180, the largest perfect square that can factor out of 180 is 36. So we're going to get root 36 times root 5. That's going to be equal to just 6 root 5. Root 36, we know that that's just equal to 6. So we end up with 15 plus 3 root 5, minus 6 root 5 minus 6 all over 12, and that's just going to end up giving us 9 minus 3 root 5 over 12, and that simplifies to 3 minus root 5 over 4. Okay, so again, being careful with the signs there and doing the simplifying. This is as simple a form as we can get from that. Now, we don't necessarily have to simplify, but sometimes we have a reason to do so, and so it's good to know how to do it. Okay. Next one, solve for the variable or variables. So again, we're looking to get the base common on both sides. That's clearly going to be 7 here. So we have 7 squared to the 4x minus 5 is equal to 7 cubed to the 2x plus 1. And that means that we get 7 to the 2 times 4x minus 5, or 8x minus 10, is equal to 7 to the 6x plus 3. Once we have the base the same and the values the same on both sides, then that only happens when the exponents are equivalent. So we can now say that this must be true. We get 2x minus 10 is equal to 3, 2x is equal to 13, x is equal to 6.5. So if I plug 6.5 back in here and evaluate both of those, I'll get the same value. All right, this one, a little harder just because the 1/8 is a little harder to recognize a power of 2, but we know that 8 is equal to 2 to the third, so 1 over 8 is equal to 2 to the negative third. So we get 2 to the negative third to the x plus 5 is equal to 2 to the fifth to the x minus 3. So that means we're going to get negative 3 times x plus 5, or negative 3x minus 15 is equal to 5x minus 15. We add 15 on both sides, we get negative 3x is equal to 5x, and that only happens when x is equal to 0. That's our solution. Okay, solve by completing the square, use fractions, find the x value and the y value of the vertex. All right, so let's first divide everything through by 3 here. So we're going to get x squared minus 3x is equal to 10 thirds. We're going to add half of negative 3 squared, so we're going to add negative 3 over 2 squared to both sides. And that's going to factor here to x minus 3 over 2 squared is equal to 10 thirds plus 9 fourths. And if we want to combine those into the same fraction, and with the same denominator rather, we would need to use 3 times 4 as that denominator. So we would multiply to get 4 times 10 over 4 times 3 plus 3 times 9 over 3 times 4 gives us 40 plus 27 over 12 is equal to 67 over 12. So we get x minus 3 halves is equal to plus or minus the square root of 67 over 12. Okay, so that means that we get x is equal to 3 halves plus or minus the square root of 67 over 12. Okay, y value of x value of the vertex is just going to be 3/2. Y value will be what we get when we plug 3/2 into the our equation, which is 3x squared minus 9x minus 10. So we get 3 times 3/2 squared minus 9 times 3/2 minus 10. And that means that we would end up with 3 times 9/4 minus 27 over 2 minus 10 is going to give us 27/4. I'm going to change this to negative 54/4 minus 40 over 4 is going to give us negative 27 over 4 is going to give us negative 67 over 4. So that's our vertex, 3/2, negative 67 over 4. Okay, intersection point. We're going to set these two equal to each other. And that's going to give us 2x plus 3 is equal to x squared minus x minus 10. Let's set the left side equal to 0 by subtracting 2x and 3 to get x squared minus 3x minus 13, not factorable, so we'll use the quadratic formula to get negative b, negative of negative 3, plus or minus the square root of b squared minus 4ac, 4 times 1, times negative 13, all over 2a, or 2. That's going to give us 3 plus or minus the square root of, so we have 9 plus 52, or 61, over 2. So we get 3/2 plus root 61 over 2, 3/2 minus root 61 over 2. Now notice we also need to find the x, or rather the y coordinate. Well, it'll be a lot easier to plug it into this than to the other. So we're going to get y is equal to 2 times 3/2 plus root 61 over 2 plus 3 is going to be y is equal to 3 plus root 61 plus 3, or y is equal to 6 plus root 61. Here we'll get y is equal to 2 times 3/2 minus root 61 over 2 plus 3 is going to give us y is equal to 3 minus root 61 plus 3. So y would be equal to 6 minus root 61. And so that means that we would have, as our intersection points, we'd have 3/2 plus root 61 over 2, comma, 6 plus root 61, 3/2 minus root 61 over 2, comma, 6 minus root 61. Okay, those would be our two. Oops. Okay, and that is it.